Welcome to the fifth part of Strand 4.2. In this part, we are going to be looking at the chemistry of alkynes, which is a third organic compound in the series of hydrocarbons. If you compare the general properties of all the organic compounds that we have studied so far, let's compare and contrast. Alkanes, we said the general formula was CnH2n plus 2. Alkenes were CnH2n, while for alkynes the general formula is CnH2n minus 2. So let's see how we are going to be writing the molecular formula for alkynes and drawing the structural formula of these organic compounds. Starting with the first organic compound, which is 2 carbon atoms. Now alkynes are unsaturated molecules because they contain a triple bond between the carbon atoms. Therefore, it is important that the minimum number of carbon atom in the alkyne should be 2. So if carbon is 2, hydrogen will be 2. According to the general formula, carbon is 2, hydrogen will be 2 times 2, which is 4. 4 minus 2 is 2. So C2H2. Ethyne, because the carbon prefix is eth, 2 carbon, and the suffix, which is the ending name, will be yn, commonly known as acetylene. So we are going to be drawing the 2 carbon atoms first. And there is a triple bond between the carbon atom. Each carbon should have 4 bonds. Now the 3 bonds are already there for each carbon. Therefore, the 4th bond will be the bond with the hydrogen atom. So this is how the structure of ethyne molecule looks like. Next, we have 3rd carbon. So let's see if you are able to work out the molecular formula of 3 carbon alkynes. If carbon is 3, hydrogen will be 2 times 3, which is 6. 6 minus 2 is 4. So it is C3H4. 3 carbons prefix is prop, so it is called propyne. We are drawing the carbon atoms first. So 3 carbon atoms, let's draw them. Put a triple bond between any 2 carbon atoms. The carbon atom which contains a triple bond will be the lowest number of carbon atom, which means this carbon atom will be carbon 1, that's carbon 2, and this will be carbon number 3. And then the rest of the bond will be occupied by the hydrogen atom, as we can see here. So this particular carbon number 2 has already 4 bonds. 3 plus 1, that's 4. Okay. Next we have 4 carbon atoms. 4 carbon atoms, hydrogen will be 6. The prefix will be but. Now we are going to be putting the triple bond in 2 different ways. So let's draw our carbon atoms first. So we will draw 4 carbon atoms. You can see I have put a triple bond on carbon number 1, and then the hydrogen atoms will be occupying the rest of the bond. Okay, so in this case, the carbon which contains a triple bond will be the lowest number, which is carbon number 1, that's carbon 2, carbon 3, and that's carbon 4. So once again, the prefix is but, but because the triple bond is on carbon 1, it is but1-ine. Why we cannot say it is prop1-ine? Because it doesn't really matter. We can put a triple bond on the right, or we can put the triple bond on the left. It will still fall on carbon number 1. The other way we can draw a 4 carbon atom alkyne is by putting the triple bond elsewhere apart from carbon 1. So we are going to put the 4 carbon atoms now, and you can see the triple bond now has been placed in the middle. Okay, let's complete the structure now. So that is C4H6. Number is going to start either from the left or from the right, both of which is going to give the lowest number on the carbon triple bond as number 2. So you can see the triple bond is actually between carbon 2 and 3. So we choose the lowest number, which is but 2. Just like alkanes and alkenes, alkynes also exist as branch organic compounds. Now we follow the same set of rules that we did for alkene and alkynes. Alkenes, that is, we start off by identifying our parent chain. The parent chain is going to contain the functional group, in this case, which is going to be the triple bond. So the triple bond is going to be part of the parent chain. Now in this case, we will see that this group of carbon atoms, they are the longest, plus there is a functional group which is a triple bond. Now we will start with the prefix. 5 carbon atom, the prefix is pent. The position of the triple bond also plays a very important role. So the triple bond, according to our, we looked at the rules, the triple bond should be on the lowest carbon atom, which is why this carbon on the left should be carbon 1, that's carbon 2, 3, that's carbon number 4, and that's carbon number 5. The triple bond is on carbon 2, so it will be pent 2 YNE, pent 2 ine. Now attached to the pentyne you have a branch which is 1 carbon. A 1 carbon branch contains the prefix meth. So it will be methyl. So all we have to do is put them together. This methyl is falling on carbon number 4, so it will be 4-methyl pent 2 ine. Next up, we are going to be looking at how ethyne molecules are prepared in the lab. Ethyne is prepared in the lab by adding water to calcium carbide. Calcium carbide are a special group of ionic substances which are they play a very important role in explosives. Explosives are actually, most of the explosives, they are made using calcium carbide as a raw material. Just 1 drop of water on calcium carbonate is going to give a highly exothermic reaction, releasing a lot of ethane gas. So the reaction that happens is this here. The formula of calcium carbide is CaC2. So calcium carbide reacts with water to give you ethane plus calcium hydroxide. Calcium carbide, you can see, contains 2 carbons, C2. So all you have to do is pick the C2 from ethane and pick the H2 from water. So C2H2 will be ethane and the rest will be calcium with the OH giving you calcium hydroxide. And this is the laboratory setup of how ethane can be prepared. As you can see here, calcium carbonate is put in the flask, water is added through the thistle funnel, and then there is a liberation of ethane gas. Calcium hydroxide is soluble, so it's going to stay over here. This is lime water. Okay, so the ethane is going to travel down the tube into the gas jar where it is collected by downward displacement of water, because ethane is insoluble in water. So let's watch a video to see how ethane molecules can actually be prepared in the lab.
Of ethane. The operation of ethane is shown. The apparatus used in the preparation of ethane is shown on the frame. In this method, a few pieces of calcium carbide are taken in a conical flask fitted with a dropping funnel and a delivery tube. The air present in the flask is replaced by oil gas as shown in the animation because acetylene forms an explosive mixture with air. Water is taken in the dropping funnel and allowed to fall into the flask clockwise. The reaction takes place vigorously and ethine gas is produced. Ethine gas so produced is collected over water by downward displacement of water.
The reactions involving alkynes are similar to the ones that we have studied for alkenes. Just like alkenes, alkynes also undergo addition reaction. However, there is a difference between the two. The addition reaction of alkynes are far more faster compared to alkenes, which are faster than alkanes. Now, in this reaction of hydrogenation, atoms of hydrogen are added to the carbon atoms in the double bond or a triple bond. The triple bond is going to break into double bond first, which is going to later break into a single bond. Similar to alkene addition reaction of hydrogen, a catalyst of nickel or platinum is used to catalyze a reaction in the presence of temperatures from 150 degrees to 180 degrees temperature. So alkyne, which is ethine plus hydrogen, is going to yield ethene as an intermediate product. The triple bond is going to break into a double bond, as we can see here in this reaction. The hydrogen atoms remain the same. Nothing is happening to them. Now the carbon atom should be having 4 bonds, and the 4th bond is going to be occupied by the added hydrogen. So this double bonded compound very quickly reacts with excess hydrogen. You can see in this reaction of addition of hydrogen to alkynes, there is excess of hydrogen added. So this double bond now is going to break into single bond. Everything that is attached to the carbon atoms remain the same. The one hydrogens in black, the ones in red, and now the 4th bond will be the added hydrogen that is going to produce ethane. So this is how addition of alkynes are different from addition of alkenes. The next kind of reaction that we are going to be looking at is halogenation. Halogenation is a reaction where alkynes react with halogens. Alkenes also had halogenation reaction, but the difference was that halogenation of alkane required a catalyst and it was a very slow reaction, while halogenation of alkenes were a faster reaction compared to halogenation of alkynes, which are very rapid. So we are going to experience the same principle here in this reaction. Since there is a reaction with bromine, there will be an expected color change from brown to colorless. And as such, bromination is used as a diagnostic test to distinguish between alkane, alkene and alkyne. So if you are given 3 colorless liquids, one containing alkene, alkene and alkyne, and you are asked to distinguish between the 3 liquids through experimental procedure, this is what you are going to be doing. React all the 3 compounds with bromine and observe the rate of the reaction. The fastest reaction is going to be the alkyne, and that alkyne is going to be a very rapid decolorization from brown to colorless, followed by the decolorization of alkene from brown to colorless, and then alkane will only decolorize if sunlight is present. And also a very important thing to note here is when this alkane is exposed to sunlight, it is going to form a precipitate. So let's look at this particular reaction now. The triple bond is breaking into a double bond. Hydrogen atoms remain the same as they were, but the 4th bond will be occupied by a bromine atom. The same thing happening here. Now you can see that we have produced a different set of intermediate products. This is groups in a halide. So we are going to look at the parent chain carbon atom in a double bond. So 2 carbon atoms is ethene, and the 2 bromines, they act as branches. They are on different carbons, so that can be carbon 1 and this is carbon 2. Therefore, this organic compound is 1,2-dibromoethene. This 1,2-dibromoethene is going to react with further bromine molecules to give a saturated hydrocarbon. The double bond will break into single bond. Everything that were in the molecule will remain there. Hydrogen and the bromine, they are going to remain the same. But the fourth bond will be occupied by another bromine. So now you can see that this one has also created a branch alkyl halide. It's an alkyl halide. Okay. So how do you name this alkyl pattern change, which is a carbon group? So 2 carbon atoms in a single bond. It's ethane. Carbon 1, one of that can be carbon 1, one of that can be carbon 2. 4 bromine atoms, which are branches. There are 4 branches this time. And we are going to position each branch separately. So carbon 1, this branch is on carbon 1, this is on carbon 2, and that's also on carbon 2. So the name will be 1,1,2,2 tetra. Tetra because there are 4 branches of the same kind. 1,1,2,2 tetrabromoethane. Okay, so the color change here will be brown due to the bromine, and it will turn to colorless because these alkyl halides are colorless compounds. And then finally, to conclude the lesson, I'm giving you a question to think about. Based on the concept that I have discussed with you, you need to identify the product for the addition reaction of alkene, which is ethene, with the following molecules. Write the structural equation of ethene with hydrogen, hydrogen chloride, and water, and predict the outcome of the structural formula. So you need to identify how the addition reaction proceeds with each of these molecules with ethene. So students, I hope you have understood the concept of the reactions and chemistry of alkane, alkene, and alkynes. Go through your notes. You can see there is a table there. Use the table to compare and contrast the different properties, the different way the names are written, the different ways they are formed, and definitely the reactions. Until then, you have to take care, keep revising your work, be positive. Okay, bye.